All right, this is section 8.4 on adding and subtracting radicals. We're going to go over problems numbers 9 through 13 from our video notes. So just a quick review from the last video, part 1. In order to add or subtract radicals, they have to have the same index and the same value inside the radical. So we need those two things to happen. So if we take a look at example 9 here, they have the same index, they're both square roots, so their index are both 2. But the problem is this one has a 6 and this one has a 24, so it can't be simplified as it is. So in order to see if it could be simplified, we have to make sure that both of these radicals are completely simplified. So we learned how to do that in the previous section. So remember, to know if a radical can be simplified, we have to think if, so 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. If any of these perfect square numbers can go into this number here, it's not simplified. So since none of these numbers can go in a 6, this is already simplified. But since 4 can go into 24, we can simplify the square root of 24 as square root of 4 times square root of 6, and the square root of 4 is 2. So that means we can take square root of 24 out, and we can replace it with 2 rad 6. And then this 2 is already here, so we're going to bring it down. And remember, there's multiplication going on right there, because a 2 next to a radical, when there's nothing in between, it means multiply. So now our problem becomes 2 rad 6 minus 4 rad 6. So just to recap, we could also take 24 when we're simplifying it, and we could do a factor tree and pick any 2 numbers. So for example, we could do 2 times 12, and then we keep going until all the numbers are prime. And remember, prime means nothing goes into it other than 1 in itself. So then when they're all prime, because the index here is a 2, it's an imaginary 2 right here, we're looking for a group of 2 that matches, so those 2, but only 1 survives. Remember our little story that this is the jail, and it needs this many to escape, but only 1 makes it out, one of the 2s. And then these 2 here don't match, so they're stuck inside, so 2 times 3 is 6. So remember, those are our 2 ways to simplify radicals. If you need more practice on that, please refer to the previous section. Okay, so back to our problem here. Now that these match, we are allowed to do 2 minus 4. So again, 2 minus 4 is negative 2 rad 6. And then again, remember, if we want to check this, we could type the original problem into our calculator. So that would be 2 times the square root of 6 minus 2 times the square root of 24. And then we would write down the decimal approximation, so it's about negative 4.89, etc. And then I'm going to type this into my calculator, negative 2 times the square root of 6. And you could see we get the same thing, so then we know, okay, awesome, that is equivalent. So if these can't be made to be the same value, then that would be our answer. But because these, we can make these match, the radicals match, we are allowed to simplify and subtract them. Okay, so now if we take a look at number 10, we have 3 radicals. We can't do anything right now because they don't match. They have the same index. They're both square, all 3 of them are square roots. So we're going to go ahead and simplify each one of these. Feel free to pause the video and simplify them yourself, and then check back with the video to see if you are correct. So I'm going to start with the square root of 12. I can break that down into square root of 4 times square root of 3. 4 times 3 is 12. And the square root of 4 is 2. Can't do anything with the square root of 3, so we're going to take out the square root of 12 and replace it with 2 rad 3 in its place. Okay, so now we're going to do that with the square root of 48. So with the square root of 48, I know that 4 goes into it and 16, so this can be simplified. Now since 48 is a higher number, you might want to, instead of using the perfect square list, which you can break it down into 16 times 3. I just want to kind of review both methods. The other way is you can use any two numbers you want, so like 6 times 8, and then keep going until there's only prime factors at the end of the tree. And then remember, think of this like the jail. Since the index is 2, we're looking for two that match. So this one and this one, but only one makes it out. And then this one and this one, but only one makes it out. And then the 3 is stuck inside. So we would get 4 rad 3. So that means we can take out the square root of 48 and replace it with 4 rad 3. But there was already this 2 here. So that would make it 8 rad 3 here. Okay, so these match. We can add them together or we can wait. I'm going to go ahead and simplify the square root of 75. So I'm going to take the square root of 75. I'm going to go ahead and break it down into square root of 25 times 3. And square root of 25 is 5. So we would get 5 rad 3. So again, I'm bouncing back and forth between the two different ways to simplify radicals. This was with a factor tree, and this one was using the perfect square list because I knew that 25 is on the list and it goes into 75, and the square root of 25 is 5. So it's up to you as long as you get 5 rad 3. So I'm going to take this out and replace it with 5 rad 3. Now these all don't need a match. If only 2 of them match, you can only combine those two. So since they all match, I'm going to go ahead, and it doesn't matter the order you do it, so I'm going to go ahead and do these two together. So 2 rad 3 plus 8 rad 3, that's 10 rad 3, minus 5 rad 3, so now we can put these two together, and 10 minus 5 is 5, and we would get 5 rad 3. Okay, let's go ahead and take a look at example 11 here. So now we're using cube roots. So we have to think if there's a perfect cube that goes into 16, or instead we can make a factor tree. So 2 times 8 is 16, and then 2 times 4 is 8, and keep going. And then we make our jail, and since our jail is a cube root, this time our index is a 3. We're looking for a group of 3. So 1, 2, 3, but only 1 makes it out of the jail, and then we have this 2 left inside. So that means we can get rid of this and replace it with 2 cube root 2. Okay, so now we can do that same thing. I'm going to bring down the 5 because it's already there. Now we're going to simplify the cube root of 54. So I'm going to go ahead and do a factor tree for this one. So pick any two numbers that multiply to make 54. So I could do 9 times 6. Circle them when they're prime. And since this is a cube root, we're looking for a group of this many, so 3 that match. 1, 2, 3, but only 1 makes it out. And you have this 2 left inside. So we are going to get rid of the cube root of 54 and replace it with its equivalent form, simplified form, as 3 cube root 2. So now we have this problem. The 5 was already there, and it means multiply, so 5 times 3 is 15. And if these match, the radicals match, the index matches, the radicand matches, then we are able to combine like terms. We can put these together, and that would make 17 cube root 2. Okay. Alright, let's take a look at this next one here. So this one has variables inside the radical. So this is the square root. We can break these up because there's multiplication here. So the square root of 4, so we can think of it like this. The square root of 4 and x are separate here. So the square root of 4 is 2. And then this index is 2, and it doesn't go into this exponent here. So this is completely simplified. And it already had the negative 3x in front, and when we multiply it by 2, because the square root of 4 is just 2, we don't need it in a radical, we would get negative 6x. So again, negative 3x times 2, that's just like how you would do it in regular algebra. Negative 3x times 2 is negative 6x. Okay, now over here, remember when we're simplifying variables, we ask ourselves, how many times does 2 go into 3? You could also think of it this way. There's 3 x's being multiplied inside, and the index is 2, so we're looking for a group of 2, and there's only one group, and only one of them makes it out, and this one's stuck inside. So remember, you could just divide. 2 goes into 3 one time, so that's how I know there's one x outside, and then there's 1 left over. So again, we could just divide 2 into 3, goes in once, and 1 left. So that's why there's 1 inside and 1 outside. And there was already this 2 here. So I'm going to bring that down. And if these match, which they do, then we can do negative 6x plus 2x. We're allowed to add or subtract what's on the outside. So since these are like terms, we can combine them, and we could do negative 6x plus 2x, which is negative 4x, and then these are the same. And that would be our answer. Now, if you wanted to check these problems that have variables, you would just have to plug in a random number. So you can go ahead and plug in 5 for all the x's. Put this in your calculator and then put 5 here and here. So you can also check these ones with the variables. If you need help with that, feel free to contact me. Alright, let's take a look at one more example here. Square root of 7, this is already simplified, and we can combine the 3 square root of 7 with the 4 square root of 7, because these are like terms. So 3 plus 4 is 7, and then the radical part stays the same. We don't add these, they need to just be like terms. And then here we can combine a negative 1 and a negative 3 because the radical parts are both cube root x's. So we would do negative 1 minus 3, which is negative 4 rad x. So it's a cube root though, so we need to make sure the cube root remains there. So we could leave our answer this way, or usually we put the one without the variable last. So I'm going to also write it as negative 4 cube root x plus 7 rad 7. So I would accept both of these answers. This one would be the best one because the x terms always go in front and the constants go at the end.